On number 4, we have 2 6-sided dice that are being rolled. One of them is going to be red, one of them is going to be green. So I already kind of outlined what my sample space is going to look like. But for part A, I just want the probability that the red die is a 5, which means if I'm only looking at these red results up here, there's only one way to get 5, but there are 6 things that could have happened. For part B, I want the probability of doubles. Doubles would be when there's a 1 and a 1, a 2 and a 2, a 3 and a 3, 4, 4, 5, 5, and a 6, 6. Of this whole sample space, 6 of them were doubles, and there were 36 things on that chart. So again, it turns out to be 1 out of 6 for both of those probabilities, which it's fair to also put the decimal approximation for that. The probability that the sum of the dice is greater than 8. So for example, a number greater than 8 is 9. 6 plus 3 is 9. 5 plus 4 is 9. 4 plus 5, and 3 plus 6. So there are lots of ways to get 9s, 10s, 11s, and 12s. If you count all of them up, 8, there should be 10 of those 36 results, as long as I counted correctly, that are more than 8. 10 out of 36. So we can say it's 5 out of 18, which is approximately 0.278. So then part D, what's the probability that the sum of the dice is greater than 8, given that the green dice is a 3? We have a limiting condition now. The green dice has to be a 3. So if the green dice is a 3, there are only 6 things that can happen. Of those 6 things, one of them is that your dice is greater than 8. Your sum, I'm sorry, is greater than 8. So this is another one that could be 0.167. Now if I know that the sum of my, if I know that the sum of the dice is 9, so I know that I have one of these things that's happening, what's the probability that the red die is a 5? So there are 4 ways to have a sum of 9. You're looking at them. Of those 4 ways, only one of them has a red 5 that created it. So you'd have a 1 in 4 chance of that occurring, given that you know that your sum is 9 already.